All right, so we are doing lesson 12.3, which is on page 183 in your consumable, where we are looking at the final form of a linear equation that we can deal with. We've been dealing with slope-intercept form and point-slope form, which have been nice because those equations actually give us two pieces of information that we can use to explain a certain situation about the linear equation, and we can use those pieces of information to graph our linear equation. What we're going to be learning today is standard form of a linear equation, and it's not as nice as slope-intercept form or point-slope form where it gives us information. We'll have to do some converting in order to use the standard form. We're only going to talk briefly about standard form because, again, we're going to do a lot of converting to slope-intercept form to use it. So our learning targets for today, we are going to be able to write the equation of a line in standard form, and we are going to be able to use the standard form of a linear equation to solve problems. So a linear equation can be written in the form ax plus by equals c, where a, b, and c are constants, and a and b are both not zero. So now when we were dealing with slope-intercept form, the equation gave us the slope and the y-intercept. And then we were dealing with point-slope form. It gave us the slope, and then it gave us a point in our graph. I will note that for standard form, the A, the B, and the C don't really give us anything about the graph in themselves. A is not my slope, B is not my y-intercept, C is not my slope. They're not points. So we need to take that into consideration, which is why we're going to be doing a lot of converting to deal with standard form. So writing this out in our equation, standard form of a linear equation is ax plus by equals c. And now with standard form, again, it's not as nice and friendly because we have to have some rules. A needs to be greater than or equal to 0. So if A is negative, we're going to need to do some work to get that not negative. A and B both can't be 0 because if they're both 0, C would be 0. And yes, that we wouldn't have a linear equation. And then A, B, and C must be integers whose greatest common factor is 1. So they need to be whole numbers. So A, B, and C need to be whole numbers. So if they're fractions, we're going to have to do some multiplying. And then their greatest common factor is 1. So if we can divide by a common number to reduce those A, B, and C's, then we're going to need to do that. So what's nice about standard form is with some quick math, we can easily find both my x-intercept, my y-intercept, and my slope. So it says you can use the coefficients of this form of the equation to find the x-intercept, y-intercept, and slope. So I'm just going to create a standard form of a linear equation that we can do that. So let's say we're dealing with the linear equation 4x plus 3y is equal to 6. So this is in standard form. A is greater than or equal to 0. A and B are both not 0. And then the greatest common factor between 4, 3, and 6 is 1. So this is in good standard form. So then it says to determine the x-intercept. So the x-intercept is where it crosses the x-axis. So when y is 0, so in order to find my x-intercept, I'm just going to plug in 0 for y. So we get 4x plus 3 times 0 is equal to 6. Well, 3 times 0 is 0. So we're dealing with the equation 4x equals 6. Dividing both sides by 4. X is going to be equal to 6/4 or 1.5. So we know it crosses the x-intercept at the point 1.50. And then we can find our y-intercept easily where it crosses my y-axis, which is when x is 0. So plugging 0 in for x. 4 times 0 plus 3y is equal to 6. Well, 4 times 0 is 0. So really we're just dealing with the equation 3y is equal to 6. Dividing both sides by 3. We get y is equal to 2. So we know it crosses the y-axis at the point 0, 2. So there's my y-intercept. So with standard form, it's pretty easy to find my x-intercept and my y-intercept with a little bit of division. And then it says write ax plus by equals c in slope-intercept form to find the slope. So again, my a, my b, and my c are not my intercepts. They're not my slopes. They're not a point. In order to really use my standard form, I'm going to want to convert it to slope-intercept form. So converting this into slope-intercept form, and I'm going to zoom in so I have more room to write. So we have 4x plus 3y is equal to 6. To get it to slope-intercept form, remember that's y equals mx plus b. I'm going to want to move the x term to the other side of the equation. So I'm going to subtract 4x, subtract 4x. So we get 3y is equal to negative 4x plus 6. And then we're going to need to divide everything by 3. So 3 divided by 3 is 1, so we're dealing with 1y. We have negative 4 divided by 3. Well, we can't do that fully, so we're just going to leave it as negative 4/3 x. And then 6 divided by 3 is 2, so positive 2. So then this is equation in slope-intercept form, and then I can easily identify my slope, which is negative 4/3. So negative 4/3 is my m. So that's my slope. We're really going to want to mainly convert these into slope-intercept form to use it. So going on to some more problems, it says the definition of the standard form states that both a and b are not 0. However, one of a or b may be equal to 0. So it says write the standard form if a is equal to 0. So suppose a is 0, b is negative 1, and c is 3. Write the equation of the line in standard form. Well, we'd have 0x minus 1y is equal to 3. 0 times x is going to be 0, so we get negative 1y is equal to 3. Dividing both sides by negative 1, we get y is equal to negative 3. And it says graph the line on the grid in the My Notes section. Describe the graph. What is the slope? Well, y equals negative 3. That's going to be one of our horizontal lines, and it's going to occur at negative 3. So it's going to be a horizontal line at negative 3. So if a is 0, we're going to be dealing with a horizontal line. And my slope would be 0. So then it says write the standard form if b is 0. So suppose a is 1, b is 0, and c is negative 6. Write the equation of the line. So we'd have 1x, or just x, plus 0y is equal to negative 6. Well, 0 times y is 0, so we get x is equal to negative 6. This is when x is negative 6, so that's going to be one of our vertical lines, and it's going to occur when x is negative 6. So it doesn't matter what y is, x is always going to be negative 6. So if we have an x equals, we're going to be dealing with a vertical line, and the slopes of vertical lines are going to be undefined. So if a is 0, we're going to be dealing with a horizontal line. If b is 0, we're going to be dealing with a vertical line. Going to the next page, it says write 3x plus 2y equals the 8 in slope-intercept form. So again, I'm going to want to move the x term to the other side by subtracting 3x. Subtract 3x, so we get 2y is equal to negative 3x plus 8. I need y to be on its own, so I'm going to divide everything by 2. So we get 2 divided by 2 is 1, so we get y. Negative 3 divided by 2 is not a nice number, so we're just going to leave it as negative 3, 2. Negative 3 over 2. And what I mean by not nice number, not an integer. It's just 1.5. X. And then 8 divided by 2 is 4. So this is it in slope-intercept form. We can also convert point slope form or slope-intercept form to standard form. In order to do that, we're going to want to do some simplifying and then put in our terms on the right side. So when it's in point slope form, we're going to start with distributing the 2 to the parentheses. So you get y minus 7 is equal to 2x plus 2. I'm going to want to move the 7 to the other side by adding 7. So we're going to add 7. So you get y is equal to 2x. 2 plus 7 is 9 plus 9. And then now it's in slope-intercept form, so now we're going to want to switch it over to standard form. So we're going to move the x term to the other side. So we're going to subtract 2x, subtract 2x. So we get negative 2x plus y is equal to 9. Now, some of us may stop there and be like, oh, it's in standard form, but remember those rules. A needs to be greater than or equal to 0, meaning we need to get rid of this negative. In order to make something a positive that is a negative, all we need to do is multiply it by a negative, because a negative times a negative is a positive. So what we can do, we can just multiply it by negative 1. But if I multiply the negative 2x by negative 1, I need to multiply everything by negative 1. So we get negative 1 times negative 2, which is positive 2x. Negative 1 times y is negative y. And 9 times negative 1 is negative 9. So now it's in correct standard form. All right, come back for part 2 when we finish this lesson.